We're going to look at some examples of factoring with the sum and difference of cubes. We're going to use this formula. In my class, I will give you the formula to use, but for some of you, you may need to memorize the formula. As you're looking at it, you'll notice that the sum of cubes begins with the binomial that is the sum, and then these signs alternate. So you have a plus sign here and then a minus sign next. It's a squared minus the product of a times b, and then this last term is always positive, so plus b squared. Second one's very similar. For the difference of cubes, you start with the difference, a minus b. The next term's the same, a squared, and then notice how those signs alternate again. You've got minus here and plus here, then the product of a times b, and that same last term of b squared. Well, let's start with some examples. I want to start off with a simple example and then we'll build from there. For the first example, let's take a look at x cubed plus 8. This one is a sum, and in order to figure out how I'm going to factor that, I need to decide what my a is and what my b is so I can plug that into the formula. A and b are the values that have been cubed. So for x cubed, a is x because x was cubed, and for 8 is 2 cubed, 2 times 2 times 2. So that value b is 2, and that's because 2 cubed equals 8. So then we want to plug in an x anywhere that we see an a up in this formula, and we want to plug in a 2 anywhere that we see a b in the formula. So I just go back to the formula and start replacing those values with x and 2. So my factorization then starts out with their sum, the sum being x plus 2, and then I go to a squared, but a now is x, so I get x squared, then the minus sign, a times b, so that's x times 2, or you could write the 2 first, and then on the end it's b squared. For now I'm going to write it as 2 squared so you can see what I did, but I'll clean it up in the next step. So I've just replaced the a's and b's in my sum formula with the x and the 2, since those are what were cubed. I'm going to clean my answer up just a little bit and write it as x plus 2, x squared, 2 is my coefficient, negative 2 is, so I'm going to write minus 2x plus 2 squared, which is 4. And this would be the factorization for x cubed plus 8. Let's look at a second one. So for our second example, let's take a look at, let's do 2y cubed minus 2. In this one, the very first thing that we look for always is a GCF, and I do have a GCF, a greatest common factor, which is something that divides into both of my terms. That would be a 2. So I'm going to start by factoring that 2 out. So as I factor the 2 out, and you can think of this as dividing it out, so I'm dividing both terms here by the 2, and that 2 is going to pull out in front. So I get 2, and then what I'm left with is y cubed minus 2 divided by 2, which is 1. Now I have a difference of cubes, and in order to factor this one using the formula that I've got up here on the top, I need to decide what a and b are. A is the first value that's cubed, so that is going to be a y, so a is equal to y, and then b is what was cubed to get to 1, which is 1. And again, that's because 1 cubed equals 1. So in my formula, wherever I see an a, I'm going to replace that with a y, so here, here, and here. And wherever I see a b, I'm going to replace that with a 1. So there's a b, and then I'm going to square b at the end. In my factorization, I remember to pull the 2 along since that's my GCF, so it's going to be 2 times the difference, a minus b, but now a and b are y and 1, so y minus 1. And then I need a squared, so that's y squared, plus comes next, a times b, which is going to be y times 1. I'm going to write it all out so you can see, and then plus b squared. So b is 1, so plus 1 squared. And I'm going to clean that up just a little bit. There's my GCF of 2, y minus 1, and then y squared. I don't need that 1 there. I could have it, but I don't need it. Plus y, and then 1 squared is 1. This is my fact. Let's do a third example. For the third example, let's look at 27 m cubed plus, let's do 27m cubed plus 125. So as I'm working this one through, I want to use my sum of cubes formula, which is up above, but in order to do that, I need to decide what got cubed. With the 27 and the m cubed, I'm going to do the coefficient and the variable. So for this one, a is 3 cubed is 27. So a is 3 times m. And again, that's because 3m cubed is, or 3m quantity cubed is 27m cubed. And then 125, you might need to think about that a little bit, but b is 5. 5 cubed is 5 times 5 times 5. That would be 25 times 5, which gives us the 125. So we have a 3m that's going to go into the formula and a 5 that's going to go into the formula. I'm going to write the formula right up above here. It's a plus b, a squared minus ab, whoops, and then plus, I'll just do that, and then plus b squared. So as I fill everything in here, I'm going to replace a with a 3m and b with a 5. Okay, here I go. So it's 3m plus 5, a plus b, and then a squared, so it's the entire quantity, 3m squared. For right now, I'm going to write it this way, 3m quantity squared minus a times b, so minus a, which is 3m, times b, which is 5, and then on the end, we have plus b squared, so plus 5 squared. If I clean this up, I'm going to do it on a separate piece of paper because I'm almost out of room. If I clean this one up, it's going to look like this. So this equals 3m plus 5, 3m squared, that's going to be 9 for the 3 squared, and then m squared. So 9m squared minus, the coefficient is going to be negative 3 times 5, so 15m plus 5 squared, which is 25, so plus 25. And that's my factorization. The nice thing about the formula is you're guaranteed that trinomial does not factor any further. Let's do one final example. For the last one, let's take, let's do, how about 8/27 x cubed minus, how about minus 64y cubed? This one is a difference of squares, and I look for something in common between everything. I do notice this 8, but I want to hang on to it because I really want to think of 8 and the 27 as something cubed, and the 64 also as something cubed. I'm going to end up using my difference of cubes formula, and I'll write it up above here, a minus b, a squared plus, because the signs alternate, ab plus b squared. So I'm going to use that formula for this example. Okay, let's move it up so we've got some more room. I need to decide what a is. As I'm deciding what a is, I just really break this down, and I decide what got cubed to be 8. So here's my fraction. It was a 2. What got cubed to be 27? That's a 3. And then what was cubed for the x cubed? That one was x. So, and I check it because 2 cubed over 3 cubed times x cubed equals my 8/27 x cubed. So with those fractions, just break them down. Do the numerator separate from the denominator. Now I need my b. b is 64. 64 happens to be 4 times 4 times 4. So b has a 4 to start, and then y cubed is y. So again, that's because 4y quantity cubed is equal to, 4 cubed is 64, and then I get my y cubed. So I can check each of those. Okay, so wherever I see an a up in my formula, I'm going to replace it with a 2/3 x. Wherever I see a b in my formula, I'm going to replace that with a 4y. And I'm going to bring that down here so that I've got some more room. So as I bring this down here, this is equal to, I start with the difference, a minus b. A is 2/3 x, so 2/3 x minus b, which is 4y, times, now I go to the a squared. A squared, use your parentheses because you're going to square the 2/3 times x, you'll square that whole thing, plus ab, so plus 2/3 x, there's a, times b, which is 4y, plus b squared. You're going to square the entire quantity 4y, so parentheses 4y squared. So I've got my factorization, but I have some cleaning up to do. The first set of parentheses can stay. Now I'm going to square the 2/3 x. I square the 2, I just do this separate. I square the 2 to get 4, I square the 3 and I get 9, and I square the x and I get x squared. See how I did that? So 2 squared, 3 squared, x squared. Plus, I need to multiply this coefficient out. That's part of the coefficient, that's part of the coefficient. So you can think of that 4 as 4 over 1. So 2 times 4 is 8, 3 times 1 is 3. So 8/3, my variable part is xy. And then on the end, I'm going to square the 4, so plus 16, and then I square the y to get y squared. And that is my factorization.